So I'm going to record this part of it just in case other people are having similar issues with figuring out LT-SPICE. So first thing you have to do is start a new schematic. I happen to set this background to white, so that's why it looks different on mine. So then we need to create that circuit that's in the lab. So I pulled up the new component dialog with the keyboard shortcut, or you can just click on that button. Start typing in volts to pull up voltage source. And then once you have that selected, click once. Then place a resistor. You can Control R to rotate that. Click once to place that. And then for a diode, you can either hit the keyboard shortcut D, or you can grab it from the toolbar and click once to place that. And you hit escape to get out of all of those modes. Okay, so do you have your components placed?
Yes.
Okay, so then we just wire them up. Single click each point where you want the wire to connect. And we're missing one thing, and we're missing the ground symbol. So place that at the bottom of the circuit. And now we have all of the symbols, but we also need to know the values. So for this resistor, it was a 1 kilo. Type in 1K. The voltage source, it doesn't matter because we're going to do a simulation type that's going to change the voltage over time. But we can just set it to 0, and that'll make the simulator happy to have some value that it can pretend it's going to have. So the last thing we need to do is pick a new diode. And this got a little bit complicated because I was trying to match it up with actual real diodes that we have in the lab. So what I wanted was this 1N4002 diode, and LT-SPICE does not have a model for that. So if I right-clicked on the diode and I went to pick new, and I looked through everything that was in here, I would not see the 1N4002. This one is fairly close, so we could use that. But there is a way that we can give this diode the characteristics of a 1N4002 diode. And that's with a simulation directive. Okay. And I've got highlighted in the lab document. Let's see if I can change my screen share. Right here, this is the statement that you need to copy and paste. So it's actually called a SPICE directive, not a simulation directive. But if you copy all of that, including the period at the beginning, well, you have that copied with a Control-C or a right-click copy, whatever you want to do. You can go to Edit, back in LT-SPICE. And then you're going to look for SPICE directive, which is right here. And right here, you just paste that line that was copied out of the lab report or the lab instructions. Then you hit OK, and then just click somewhere to place it. Doesn't really matter where it ends up. And this 1N4002 is the label for the diode, so we need to make sure that this diode label matches up so that the simulation program knows where to put those characteristics. Now it's going to attach them to that component. Okay, so we have values, we have components, we have this new definition for the diode, and the last thing we need to do is set up the simulation. So I'm going to hit the simulation button here. And since I don't have a simulation set up, it gives me this edit simulation command menu. And what we need to do is do a DC sweep, which is specified in the lab instructions. So we're simulating a DC sweep. And we need to know the name of the source. The name of the source is V1. It's just our default name that we get when we place the component. And this is going to be linear. So it's going to be a linear increase of voltage over time. We're going to start at 5 volts and end at, I'm sorry, we start at 0 volts, end at 5 volts, and increase in 0.01 volts increments. Okay, so that runs the simulation. And then we want to see this voltage, the voltage across the diode. Do you have that?
Just a second.
Okay.
It's not coming up. It's
Okay.
blank. It showed the chart and everything, but it's blank.
Okay. Did you click right here above the diode?
Now it's come up.
Okay. So you're probably going to see something like VN002, and that's the automatic numbering that LT-Spice is giving to the nodes or the different connections that are in this circuit. So if we want to specify that this is the diode voltage, which is done in the lab instructions, we can do that by changing the net name. And if I click on that little A symbol and say diode, now I can attach this to the node that is connecting the resistor and the diode. And nothing's going to change unless I rerun the simulation. So I'll click on this little run command again, and it's going to clear the signals because now we have a fresh simulation. And then if I click right here again, now that is going to be labeled V diode because we've given that node a name. Okay, so that's just so we can keep things straight. So the next thing that the instructions say to do is click on the voltage label. And when that happens, this cursor shows up. So when I put my mouse over that dotted line and I click and drag, I can move it all around. And while that's happening, you're going to see different voltage values changing in that little dialog right here. You see those happening?
I don't have that coming up.
Okay. Did you click on the diode up here in this simulation area?
Yeah.
Okay. And did you see these dotted lines show up?
Yes.
And when you click and drag, did you have this little pop-up menu show up? It could be in the bottom corner of your screen somewhere.
I don't see that pop up. Wait. Yeah.
Okay.
It was on your screen, so I thought 2 was on yours.
Oh, okay. Okay. So when you move the cursor now, you're seeing your values change?
Yes.
Okay. So this horizontal value right here, that is the value of the voltage source. You can see it starts at 0 and it goes all the way up to 5 volts. So that's what we configured our simulation for. It's going from 0 to 5 volts in 0.01 volt increments. But this vertical value here is what we're measuring across the diode. So that's our diode voltage. And you can see it starts off at 0 when we have 0 volts applied, and then it increases pretty much linearly. And we can compare these two values. It's a linear increase. And this is when the diode's not conducting. So I'm going to just put this in annotation mode real quick and draw this here. So if we're thinking about that VI curve for a diode, we're in forward bias, but we are below the knee voltage, and that's what's happening right here. And when we're below the knee voltage, that acts like an open switch, which means we have no current flow and we have whatever that diode voltage is equal to the voltage source. So we're expecting to see the same value horizontal and vertical right here. And that is happening up until we get to close to the knee voltage. So once that happens, then we're going to see the voltage for the diode kind of level off. And it's not going to be perfect because this is trying to simulate more real life scenario. So it's going to slowly increase. And if we had a much higher voltage applied, we would see it kind of level off around 0.7 volts. But since we're looking at a lower voltage, we're going to see it level off around 0.5, 0.6 volts.
Okay.
Get out of annotation mode here. Okay, so these two voltages are the same because the diode's not conducting right now. It's acting like an open, and so it's going to have the same voltage as the source across the diode. And then as we keep increasing that supply voltage, right around here at 0.5 volts, and then we get a little bit higher, we're going to see the horizontal value is increasing a lot, but the vertical value is increasing very little. So the voltage source is getting to be a very high value, but the voltage across the diode is holding pretty steady. So it's slowly increasing, saying this is 564 millivolts right now. And 500 millivolts is the same thing as 0.5 volts, right?
Yeah.
So this is just happening to show it in millivolts. And we're seeing this diode voltage level off, even though we have a much higher voltage source. So that's what we would expect to see for this diode here. And then what I ask you to find in the lab, let's see, I asked you to click and drag the cursor all the way over to the right edge of the graph. So that would be when we have Vs equal to 5 volts, because that's the maximum voltage that we had for the simulation. And then the vertical value right here gives the voltage for the diode. So that is 600 millivolts, or you could say it's 0.6 volts. So that's pretty close to what we expect for the knee voltage of a silicon diode, right?
Yeah.
Okay, so that would be how you can find the first value, and that would be for our circuit in the lab where we had a 5-volt source. So this is for our first circuit where we had that 5-volt source, and you just drag that cursor all the way over to the right in LT-Spice and get that measurement. And you can also get the diode current, which is what you're going to need to find. So you can get the predicted value by doing the calculation by hand, and then LT-Spice, we just need to measure one more thing here. So we've only got voltage on this graph right now, so we need to get current. And if you just mouse over the diode component, you're going to see the cursor turn into that little ammeter, which is trying to measure current. And it's got the red arrow that's showing the direction that LT-Spice thinks that current should be flowing in. And that is the direction that we also think that current should be flowing in. So we should get a positive value when we click on this. And we do. So this current is going to increase once we have enough of a voltage applied that the diode actually allows current to flow through. And we can see that happening here. This right now is still displaying values for voltage, and that's because the cursor is attached to that voltage plot. If I want to see values for the current, I have to click on the current label. So now the cursor is attached to the current plot, and I can switch between them by clicking on those labels for voltage and current. Okay, so then if I want to find the current value for 5 volts. I'm just going to drag this cursor all the way over to the right again. I see that this horizontal value is at 5 volts, so that's our voltage source is equal to 5 volts. And this current value is 4.4 milliamps approximately. You seen that on yours too?
Yes.
Okay. So those are how you get the values for LT-SPICE for the voltage and for the current. For that first part, I'll switch screens again. All right. And now this is the second circuit, and we have 0.3 volts. So this is still hooked up in forward bias, but we have a smaller voltage. So we have to figure out what's going to happen there. So you can do that analysis by hand, but I'm just going to show on LT-SPICE how we can get that without changing the simulation. So it's just going to be moving the cursor. Since we're interested in voltage, I'm going to click on that voltage label. So now this little guy is going to display voltage values. And we're looking for 0.3 volts for the voltage source. So that means that this cursor should be lined up for a horizontal value that's about 0.3 volts or 300 millivolts. Okay, so that's what we have right there. And you can see that the diode voltage, which is the vertical value, is also very close to 300 millivolts or zero 0.3 volts. So that would be how you get the measurement for that part. And then if you want to get current, you just click on the current label, and the cursor is still in the same horizontal position, but now it's giving you a current reading, which is very, very, very small. It's 6 microamps. Are you seeing that on your end too?
Yeah.
Okay. So does that make sense how we can get different simulation values for different voltage source values from this plot?
Yeah.
Okay. If you wanted to, you could just simulate it differently. Change this to 0.3 volts. And then we would need to change the simulation type. So this is the simulation command right here that starts with DC. If I right click on that, it can change the simulation type. And what we were doing before is transient simulations for like 10 microseconds. So if I run this voltage source is not going to change anymore. It's at a fixed value. And this might be what we're more familiar with at this point. So you're going to see over here, this is going to be just at a constant 29 or 294 millivolts, which is really close to 300 millivolts. So it's approximately 0.3 volts for the diode voltage. And then the current is, again, that 6 microamps. And then you can also do the same if you want to see what this would be for 5 volts. Run the simulation again because we changed the value. And you're going to see a little bit of a change because this is changing slightly over time, but it's really not too much of a fluctuation. If you look at the difference between the starting value and the ending value for this period of time, it's basically the same voltage value. So it's about 0.6 volts. And then the current is also changing very little over time. It's 4.4 milliamps. So if the cursor stuff is getting confusing, you can just do the simulation this way too. Does that make sense?
Yes.
Okay. And then it's pretty much doing very similar steps for the rest of the lab. So that should be good to hopefully get you started.
Yes, it is. I understand much more now.
Okay, great. I'm going to go ahead and stop the recording at that point.